Hi there, this is Chernins, and for today's video lesson, we'll talk about ellipses. At the end of this video lesson, you will be able to define an ellipse, find its center, foci, vertices, co-vertices, and determine its standard equation. Here's the definition of an ellipse. An ellipse is a set of all points P in a plane in such a way that the sum of its distances from two fixed points on the same plane is constant. These fixed points are called foci. The constant sum is also equal to the length of the major axis of the ellipse. I'm going to show you what does this last sentence means. We have a point on the ellipse and two lines that connect the point to the 2 points or the foci. The sum of the lengths of the lines 1 and 2 is equal to 2a or the major axis. So in the other ellipse, we have a point again and two lines, and the distances or the sum of the distances of these two lines is just equal to the major axis or 2a. So here are the parts of an ellipse. First, we have the center. The center of the ellipse has coordinate hk or 0, 0 if it is in the origin. It is the intersection between the major and minor axis. We also have the foci, denoted by f sub 1 and f sub 2. Each point is c units away from the center. Vertices, denoted by v sub 1 and v sub 2. These are the points on the ellipse, collinear with the center and foci. Each vertex is a units away from the center. V sub 1 to V sub 2 is called the major axis. Its length is 2a. We also have the co-vertices denoted by W sub 1 and W sub 2. Each co-vertex is b units away from the center. The segment through the center, perpendicular to the major axis, is the minor axis. The minor axis is 2b units long. There are two types of ellipses, the horizontal ellipse and vertical ellipse. The horizontal ellipse has a horizontal major axis, while the vertical ellipse has a vertical major axis. Please take note of the formula shown to determine the standard equation and parts of the ellipse. Now let's determine the coordinates of the center, foci, vertices, and co-vertices of the ellipse with the given equations, and then sketch the graph. So I'm going to show you the solution for all odd numbers, and the remaining numbers will be your activity. First, we have x squared over 169 plus y squared over 25 equals 1. With this equation, we can say that the ellipse is horizontal since the larger denominator is in the term that has an x variable in the numerator. So let's follow these formulas. Okay, since a squared is the larger denominator, therefore a squared is equal to 169. So, a is equal to 13. Then, b squared is equal to 25. So, b is equal to 5. To find the value of c, all we have to do is follow the formula. We have c squared equals a squared minus b squared. Therefore, c squared is equal to 169 minus 25 equals 144. So the value of c is 12. Now, let's find the coordinates for the center, foci, vertices, and co-vertices since we have the values of a, b, and c. With this equation, we can say that the center is at the origin or at 0, 0. How about the foci? Okay, the foci is at positive, negative 12, and 0. So the formula for foci is here. Okay, so we have H plus minus C and then K. So since our C is 12 and our H is 0, so 0 plus 12 is 12 and 0 minus 12 is negative 12. Therefore, our foci are, we have positive 12, 0 and negative 12, 0. For the vertices, we have this formula in our box here at the right top. So for the vertices, we have H plus minus A and then K. So our A value is 13. Therefore, so 0 plus minus 13. So we have positive and negative 13 and 0. For the co-vertices, we have the formula H and then K plus minus B. Our B is 5, so therefore our co-vertices are 0 and positive 5 and 0, negative 5. I'm going to show you the graph of this ellipse. There. So you can see the center, okay? The vertices, so we have V1 and V2, and the co-vertices, W1 and W2, and we have the foci F1 and F2. And as you can see, it is a horizontal ellipse. Next, we have 13x squared plus 4y squared equals 52. Since this given is not yet in its standard form, let's manipulate this by dividing all the terms by 52 so that the right side of the equation, which is a constant, is just 1. So dividing all the terms by 52, we will have x squared over 4 plus y squared over 13 equals 1. As you can see, it is now in its standard form. The question is, what type of ellipse is this? Yes, this is a vertical ellipse, since the denominator of the term that has a y variable is larger. Since the larger denominator is a squared, therefore a squared is equal to 13. And a is equal to square root of 13. And b squared is equal to 4. Therefore, b is equal to 2. To find the value of c, we will follow the formula. This formula, c squared is equal to a squared minus b squared. Therefore, we have c squared equals 13 minus 4, which is equal to 9. Therefore, c is equal to 3. Since we have the values of a, b, and c, we can now find the coordinates for the foci, vertices, and co-vertices. And with this form of the equation, standard equation of the ellipse, we can say that its center is at the origin or 0, 0. So we have 0, 0 there. For the foci, let's follow the formula here at the right top. So we have h and then k plus minus c. So we have a 0 and then positive, negative 3. Why positive and negative 3? Since our k is 0 and our c is 3. So 0 plus 3 is positive 3. 0 minus 3 is negative 3. For the vertices, we will follow the formula here as shown. So we have h and then k plus minus a. So the value of k is 0 and the value of a is square root of 13. Therefore, the vertices are 0 and then positive, negative square root of 13. For the vertices, the formula is h plus minus b and then k, and the value of h is 0 and the value of b is 2. So the vertices or the co-vertices are, okay, so we have positive, negative 2, and 0. I'm going to show you the graph of this ellipse. So as you can see, it is a vertical ellipse. You can also see the parts. So we have the center at 0, 0. The foci, F1 and F2. Okay, it is C units away from the center. And that is 3 units away from the center. And the vertices is A units away from the center. So that's square root of 13 from the center to the vertex. Okay, vertex to C and then C to vertex. For the co-vertices, okay, so we have W1 and W2, and it is B units away from the center. So that's the graph of the ellipse. Next, we will have 9x squared plus 16y squared plus 72x minus 96y plus 144 equals 0. Again, the equation is not yet in its standard form, so let's make this in standard form. First, let us group all the terms with x variables and terms with y variables and then move the constant on the other side. So we will get this one. Then, let us factor out the coefficient of the x squared and y squared. So, factor out 9 and then times the quantity x squared plus 8x plus, so we have 16 times the quantity y squared minus 6y equals negative 144. Now, let's factor by completing the square. Okay, so we will add 16 here and 9 here. Then, on the right side, we will also add 9. So, this is the number that we factored out, okay, from the x squared, times 16, okay, plus 16 times 9. We will get 9 times the quantity x plus 4 squared plus 16 times the quantity y minus 3 squared equals 144. Now, we will divide 144 to both sides of the equation so that the right side will be equal to 1. Okay, and then we will get the standard form, which is, okay, the quantity x plus 4 squared over 16 plus the quantity y minus 3 squared over 9 equals 1. And as you can see, from this equation, we can say that this ellipse is a horizontal ellipse. So, let's follow these formulas in identifying the parts of the ellipse. Okay, we all know that the larger number is the a squared. Therefore, a squared is equal to 16. So, a is equal to 4. B squared is equal to 9. So, b is equal to 3. To get the value of c, okay, we will use the formula a squared minus b squared. So, c squared is equal to 16 minus 9 equals 7. Therefore, c is equal to square root of 7. So, having these values for a, b, c, we can now identify the parts of the ellipse. For the center, we have, okay, the HK, which is negative 4 and 3. For the foci, okay, we will use the formula here. So, H plus minus C. So, the H is negative 4 and C is square root of 7. So, we have negative 4 plus minus square root of 7 and then 3. So, if you want to evaluate more this, so we will get negative 1.35 and 3 and negative 6.65 and 3. For the vertices, okay, we will add H okay, or h plus minus a and then k. So h is negative 4 and a is 4 to find the x coordinate for the vertices. So we have negative 4 plus minus 4 and then 3. So there are two coordinates for the vertices. We have, okay, so negative 4 plus 4, we have 0. Then just copy the k, which is 3. So we have 0, 3. And negative 4 minus 4, we have negative 8. So negative 8 and 3. For the co-vertices, we will use the formula, which is h, copy the h, which is negative 4. And then for the y coordinate, we have k plus minus b. So k is 3 and b is 3. So we have this. Then let's simplify more. We have negative 4, 6, and negative 4, 0. And this is the graph of the ellipse. So this is a horizontal ellipse. This time we will find the standard equation of the ellipse which satisfies the given conditions. I will only show the solutions for the even numbers, and for the remaining items will be your activity. Find the standard equation of the ellipse with foci negative 8, 0 and 8, 0, and the sum of the distances of any point from the foci is 20. Since the sum of its distances from two fixed points on the same plane is equal to the length of the major axis, which is 2a, 2a is 20. Given the foci, its midpoint is the center, which is the origin, and each focus is 8 units from the center. That means C is equal to 8. Since 2a is equal to 20, therefore a is equal to 10, and a squared is equal to 100. Since c is equal to 8, therefore c squared is equal to 64. To find the value of b squared, we will use the formula. Okay, so b squared is equal to a squared minus c squared, and that is 100 minus 64, which is 36. So next step here, okay, we can see that this is a horizontal ellipse based from the points of the foci. So the larger value should be the denominator of x squared. Substituting all the values, so we have the a squared and the 36 and the center, which is at the origin, we can now write the standard equation of this ellipse, which is x squared over 100 plus y squared over 36 equals 1. Find the standard equation of the ellipse with a focus at negative 915 and co-vertex at 110 with vertical major axis. To answer this, it is better to plot the points in the Cartesian plane to visualize the type of ellipse. After plotting the focus and co-vertex, make a line to where these points intersect to find the center. So we have the center at negative 9 and 10. After this, let us identify the distance from the center to the focus to find the value of c, and the distance from the center to the co-vertex to find the value of b. So the distance from the center to the focus is 5 units, and the distance from the center to the co-vertex is 10 units. You can also use the distance formula to find this as an option in finding the distances or values of a and b. Since the condition states that this ellipse has a vertical major axis, therefore it is a vertical ellipse, and we will follow this standard formula. So from the graph, we can see that the c is equal to 5 and b is equal to 10, and the center is at negative 9 and 10. So c squared, we have c squared is equal to a squared minus b squared. So let's manipulate that formula so that we can find the value of a squared, which is c squared plus b squared. Now let's substitute all the values. We will have a squared equals 5 squared plus 10 squared equals 125. So, to write the standard equation of this ellipse, let's just substitute every values. Okay, so we will now have the quantity x plus 9 squared over 100 plus the quantity y minus 10 squared over 125 equals 1. Thank you and stay safe.